Hello everyone, welcome back to our artificial intelligence and machine learning lecture series. In this session we are going to learn another important uninformed search algorithm called depth first search, or simply known as DFS. In the previous lecture we discussed breadth first search, where nodes are explored level by level. Today we will see the completely different searching strategy. Instead of exploring all neighboring nodes first, DFS explores one branch completely until it reaches the deepest possible node. Only then does it return and explore other branches. By the end of this lecture, you will understand what is the DFS, difference between DFS and depth first search and breadth first search, stack data structure, a DFS algorithm, that is a step-by-step traversal, advantages and drawbacks, applications. Depth first search, DFS, it is a recursive algorithm for traversing a tree or a graph. It is called a depth first because it starts from the root node and follows each path to its greatest depth before moving to the next path. A DFS uses a stack data structure for its implementation. The process is similar to the BFS algorithm, but the traversal order is different. We are using stack. In BFS is first in first out. Here we are using a stack principle, last in first out. The stacks follows the principle called last in first out, or LIFO. Imaging stacking books. The last book placed on the stack is the first one you remove. Similarly, the last node inserted into the stack is expanded first. This LIFO behavior makes DFS travel deeper into the search. Now let us discuss the advantages. First one, it is required very less memory, as it only needs to store a stack of the nodes on the path from the root node to current node. Okay, DFS requires very little memory, unlike breadth first search. It stores only the current path instead of storing an entire level of nodes. Therefore, DFS is much more memory efficient. Second one, it takes less time to reach the goal node than BFS when the goal node is located deep into the search tree. If the goal node is located deep inside the search tree, DFS may find it much faster than BFS. This is especially useful when we know that the required solution is likely to be located far from the root. Okay, next one more is the DFS algorithm is simple to implement using either a regression or a stack. Next, we are going to discuss about drawbacks of DFS. Although DFS has many advantages, at the same time it also has some limitations. First one, it does not guarantee the shortest path. DFS does not always return the shortest path. So even if a shorter path exists, DFS may find a longer solution first. This is one main drawback. Next, DFS may get trapped exploring a deep or finite path if cycles are not handled properly. If cycles exist inside the graph, DFS may repeatedly visit the same nodes unless we maintain a visited list. Third one, DFS is not optimal. for finding the minimum cost solution. If a finite branch exists, DFS may continue exploring forever. Therefore, DFS is not considered an optimal search algorithm. Now let us understand DFS using a simple example. In this example, S is the starting node, and suppose A is our starting node. Initially, we assume A is the starting node. The stack contains only A. Stack A visited, and then step 2, remove A from the stack and visit its children's. Suppose its children's are B and C. Since DFS uses a stack, the last inserted node will be explored first. Suppose C is pushed after B, then C will be explored first. Next, we are going to remove C, visit its childs. Continue moving deeper again, push child nodes onto the stack. Continue this process until no child node is available. When a dead end is reached, DFS performing backtracking. Here, backtracking means it returning to the previous node. Okay, then it explores the remaining unexplored branches. This process continues until the goal node is found. The major difference between BFS and DFS is BFS explores horizontally while DFS explores vertically. This is our one more example. In this example, S is the start node, G is the goal node. First starts from S and A. A have two childs, B and C, and B have a childs D and E. Okay, but search only occur A to A to B, B to D. Okay, D there is no child nodes, so it will backtracking. Backtracking means there is no child node, it will go to previous node. And then already B is in visitor list, so it will be go to E. Okay, E also has no child node, it will also have backtracking and then go to B. B is also visited, so it will be go to C. Okay, C to C only one node, which is G. Okay, G is the final goal node. Okay, now only we got goal node. Finally, a DFS traverse order is S, A, B, D, E, C, G. Okay, and we have a completeness, optimality, time complexity, space complexity. These four parameters we have to checked whether it is rectified or not. Thank you.